Hi, good afternoon. These notes are on dilations. To dilate means to enlarge or reduce the size of an object. So for example, if you look at this object A, B, C, D, this quadrilateral, and then it is shrunk down to A prime, B prime, C prime, D prime. A scale factor is a number that you're going to use which will determine how large or small an object will become. Your coordinate notation, you can write it as dk, which D stands for dilation. K is your scale factor of xy. So you multiply your x by k and you multiply your y by k. So really this just means multiply each of your coordinate points by the dilation number, which is your scale factor. So a scale factor that is greater than 1 means the object will increase. A scale factor less than 1 means the object will decrease in size. And then a dilated image will always be similar to the original image. It'll just be different in size. So this will be a non-rigid transformation. Looking at the coordinates below, we're going to identify what scale factor was used. So for example, x and y, so x is -2,4, y is 2,8. Now x prime is -6,12 and y prime is 6,24. So you just kind of look at what happened to x to get to x prime, and it looks like it multiplied by a factor of 3. And then just make sure you check with everyone and that it works for every single one, and it looks like it does, so a scale factor of 3. The next example is 5, 3, 2, 5, and then it looks like it changed to -10, -6, -4, -10. So it looks like we multiplied by a scale factor of -2. And we'll actually talk about scale factors of negatives in just a little bit. And then our third one goes from -2,4 to -1,2. So it looks like it's getting smaller, so we know it's going to be less than 1, so it's going to be a fraction. So you can kind of think about, well, how am I dividing this? And then if you're dividing, remember you can multiply by the reciprocal to give the same value. So -2 divided by 2 gives me -1. 4 divided by 2 gives me 2. So I'm dividing by 2, which is the same scale factor as 1/2. All right. Now what we're going to do is we're going to practice on the graph. So we're going to apply a scale factor of 3. We're going to write down the new prime points below, and then we're going to decide how to plot our x and y axis depending on the coordinate points, and then we're going to plot both of them on the provided graph. Now I've already done it for you on the front just to kind of save time in this video, but I decided to make my quadrant 1 really big because I knew that my points were going to stay in quadrant 1. So that's why I didn't draw it right down in the middle. I actually focused mainly on quadrant 1. So if I do multiply all these points by 3, I'll get a new point R prime of 3, 3. I'll get a new point S prime of 3, 12. And then I'll get a new T prime of 12, 3. And as you notice, the triangle did start off quite small, and then it grew larger by a scale factor of 3. So what happens if you go to the graph figures and draw lines extended from each given point and its prime? So if you look and you kind of connect this line here to here, you can see that they actually have, that it's a nice straight line. Okay. How can you tell the graphed triangle would be larger or smaller? Because the scale factor was bigger than 1. So that's what you can write there. All right. Now we're going to apply a scale factor of 1/3. So if we remember from our notes, when a scale factor is smaller than 1, it's going to make our object smaller. So again, I've already done it for you. I looked at my points and I saw that we were starting in quadrant 3 and that we were mainly going to stay in quadrant 3. So that's why I drew mine mainly focusing on quadrant 3. So I'm going to go ahead and multiply these points by 1/3 to give you those numbers. So that gives you -1, -1, 0, -3, -3, -1, -4, -3. And as you can tell, our object did start off, this trapezoid started off bigger, MNOP, and then it got smaller to this size right here. And then again, just answer these two questions. So what happens if you go to the graph figures and draw lines extended from each given point to its prime? You can see that's a nice straight line. To each of them. Okay, and they actually all go towards the origin, as I think that's what they're kind of going for. So they all come to the origin if we were to draw all the lines straight through. Okay, because our center of dilation is at 0, 0. And then how could we tell that the graph would get larger or smaller? The scale factor was less than 1, so we knew it would get smaller. All right, on the inside is some more dilation practice. So we've got this triangle here. So what do you think might happen if the scale factor is negative? And then just looking at this picture, I've kind of already given it away. It's going to definitely dilate the image. So it is definitely going to get bigger because the number is bigger than 1. Well, the absolute value of it is bigger than 1, but it's also going to flip it into its opposite quadrant. So it was in quadrant 2, now it's going to be in quadrant 4 because that negative is going to change everyone to its opposite. So right here you can write a little summary of what happened. So if we multiply everybody by -2, we get 4 -2, and 10 -2, and 4 -12. And if you look, my triangle DAB, it did grow bigger, and then it actually kind of reflected almost, because B is now down here, A is over here, and then D is right here. Okay. Does it still go through the origin? Yes, it does, if we connect all of our points. So if you connect all your prime points, it still goes through the origin because our center of dilation is the origin. And then just describe what happened to the figure, you can put that down below. All right, so right here is just a bunch of dilation practice. And then on this side is actually your unit review on everything that you've learned so far. So there's translations, reflections, rotations, and then down at the very bottom there's dilations. Now this is a really cool activity because it says if you find the coordinate points of the image underneath each transformation, and then on the same coordinate plane graph and then shade the quadrilaterals, it'll actually spell out something. So don't plot these, give the new points here, and then from your new points graph those and shade them in, and it'll actually spell out a word. Okay, so that's it for those notes. If you have any questions, I will be back on Tuesday of next week, and I will see you guys on Wednesday. So if you just want to wait to ask those questions, you can, but just make sure that you complete the inside of these notes. All right, have a great afternoon.